of carbon, examples of carbon in our daily life. Chalk, I mean that charcoal you are using to cook at home is carbon. Another example is here. I don't know how many of us have ever used a paraffin lamp. There is this lamp that uses paraffin, then it has some glass. After some time, you'll find that glass of the lamp, of the paraffin lamp, covered by a black substance called soot. That black substance is also carbon, and it is that black substance that is used to make shoe polish and carbon papers. Another example is here. We have all ever used a pencil. That lead of the pencil that writes is carbon. Then girls, ask your parents who put on earrings. Most of those earrings are made of diamond, and that is carbon. Okay, so there are very many forms of carbon, but let us start like this. We know that the atomic number of carbon is 6. So if the atomic number of carbon is 6, who can tell us the electronic configuration of carbon? Chantal, what is the electronic configuration of carbon?
2 to 4.
2 to 4, very good. That means if it has 4 electrons in the outermost shell, it is in group 4. If it has 2 energy levels, then it is in period 2 of the periodic table, and it has an atomic number of 6. Occurrence of carbon. How does carbon occur? Carbon occurs in free states and combined states. In combined states, it occurs as coal, mineral oils, and carbonates. E.g., minerals, I mean, you have ever heard of limestone? Limestone is calcium carbonate. Okay? Limestone is calcium carbonate. Then we have seashells. Now, by the way, you see that when you break an egg, that egg of a hen, that outside part is made of calcium. And all living things, carbon also exists there, like animals and plants. And we are saying as an element, it occurs both in natural form. It occurs as diamond and graphite. These ones we are going to see in detail. Then in synthetic form, it occurs as charcoal. I think you understand what I'm talking about. You agree with me that there is no man who can make diamond. There is no man who can make diamond. So man just uses the gift of nature. So diamond is the gift of nature. But man can make charcoal. So in this case, carbon exists as in synthetic form. Man can make charcoal but cannot make diamond. So that is what we are talking about. Allotropes of carbon. I want everyone to get a pen and a book. We note down something. And when I tell you to note down something, it means I will ask you in the assignment. think you already have a pen. We have two words. One word is allotrope. Allotrope. Then the other word is allotrope or allotropes. The first word is allotrope and the other word is allotropes. So let us distinguish between these two words. What is allotrope? Allotrope is like a process. Okay? Allotrope is like a process. So allotrope, that process, we are defining it as the existence of an element in more than in two or more forms, or someone can say in more than one form, but without change in physical state. Very common definition. It is short, but very common. But some people usually fail it. You wonder why. Allotrope. We are defining allotrope as the existence of an element. Allotrope is the existence of an element. So an element can exist or it can have more than one forms. An element can exist, just like we are saying carbon is the element now we are talking about. It can exist in many forms. It can exist as graphite, like I've told you, the one that makes pencils, and it can also exist as diamond, which is used to make earrings. So it is one element, but it is having more than one form. But those forms, they remain in the same physical state as the element. Meaning, if the element was a solid, then its forms in which it exists remain in solid state, not in gas and not in liquid. So allotrope is the existence of an element in more than one form or in two or more forms, but without change in physical state or in the same physical state. Have you people noted that down? It is very important. Let us now talk about allotropes. Now, those elements, like now I told you, carbon can exist in more than one form. It can exist as diamond, it can exist as graphite. Now, graphite is now an allotrope of carbon. Graphite is now an allotrope of carbon. So, what is an allotrope? And we are defining allotropes as various forms in which elements exist without change in physical state. Can we note that down? Can we note that down? Allotropes, these are various forms in which elements exist without change in physical state. Allotropes are various forms in which elements exist without change in physical state. Different allotropes of the same element always have different crystalline structures and physical properties, but the same chemical properties. So they have different crystalline structures and different physical properties, but they usually have the same chemical properties. Who can tell me why they have the similar chemical properties? Why do various allotropes have similar chemical properties? Who can tell me why, despite these elements having different crystalline structures, but they have similar physical properties and similar chemical properties? Why? The reason is because they are just forms of one element. It is still one element, but it is existing in more than one what? One forms. So, allotropes of carbon are, I had already told you, the different ways in which carbon can exist. Common allotropes of carbon are diamond and graphite. Now, diamond and graphite, you should be careful. These ones are crystalline allotropes. Diamond and graphite, those ones are crystalline allotropes. Now, the opposite of crystalline is amorphous. The opposite of crystalline is amorphous. So another form of carbon is amorphous carbon. And amorphous carbon is, for example, soot. Soot is carbon, but it comes, the way it comes, it is like in gaseous state. You remember how we used a luminous flame, that soot from luminous flame, how black it was, but it is not solid. So those are the amorphous forms of carbon. So I repeat, diamond and graphite, someone should note that diamond and graphite are crystalline forms of carbon, but we also have other forms called amorphous forms of carbon. Now, having defined allotrope and allotropes, we now look at the forms of carbon independently, each one by one. And the first form of carbon we are going to look at is diamond. Is what? Is diamond. So we shall talk about its structure. You remember when we were looking at structure and bonding, we brought in diamond and graphite to have a giant molecular structure. You remember that. So the most important thing you need to know about diamond is that its structure, the structure of diamond is here. This is the structure of diamond, and it is a common question we can ask you to draw its structure. So you need to know that the structure consists of infinite number of carbon atoms. Now, each of the carbon atoms is joined to 4 other carbon atoms. When you look at this carbon atom, where my pointer is, it is joined to 4 other carbon atoms. So where you see a dot, there is a carbon atom. So this is my carbon atom, this one, and it is joined to 4 other carbon atoms. This is 1, this is the second one, this is the third one, and this is the fourth one. So that is what I'm talking about. Each carbon atom is joined to 4 other carbon atoms. Look at this one. In the middle, it is also joined to 4. This is 1, this is 2, this is 3, and this is the 4th. Like that. So that is how the structure of carbon is. I mean the structure of graphite. But having known, when we are looking at structure and bonding, carbon also came in, formation of covalent bonds. And we said, when you write its configuration, it has 4 electrons in the outermost shell. That means it should always have 4 bonds. So, each carbon atom is joined to 4 other carbon atoms by covalent bonds, resulting into a tetrahedral arrangement. Resulting into a tetrahedral arrangement. This gives diamond crystal, a giant 3-dimensional structure. Now that one reminds you, we said the structure of carbon, graphite, and diamond is giant molecular. So this gives diamond crystal a giant 3-dimensional structure. Then the most important statement is the last one. Diamond has no mobile electrons, so it cannot conduct electricity. So we have said carbon has a valence of 4. It has 4 valence electrons, 4 electrons in the outermost shell. And when you read this statement, we are saying each carbon atom is joined to 4 other carbon atoms by covalent bonds, resulting into a tetrahedral arrangement. So if each carbon atom is joined to other carbon atoms by 4 covalent bonds, it means all electrons of carbon participate in bonding. So if each carbon atom, look at where I put my dot, this carbon atom is joined to 4 other covalent bonds. This is the first one, this is the second one, this is the third one, and this is the fourth. But remember, each covalent bond is formed by sharing 2 electrons. So each carbon atom now donates an electron to the formation of the bond. So it means carbon uses all its 4 electrons in the outermost shell for forming covalent bonds with other carbon atoms in diamond. So that is the reason why we are saying diamond has no mobile electrons, because all electrons participate in formation of covalent bonds with other compounds. So without mobile electrons, then diamond does not conduct electricity. So I want you people to note this because it is very important. You say in diamond, each of the carbon atoms is joined to 4 other carbon atoms by covalent bonds, resulting into tetrahedral arrangement. In diamond, each carbon atom is bonded to 4 other carbon atoms, resulting into a tetrahedral arrangement. So therefore, diamond has no mobile electrons. Therefore, diamond has no mobile electrons, since all its electrons participate in bonding. Since all its electrons participate in bonding. and therefore does not conduct electricity. The reason why diamond does not conduct electricity is that it does not have mobile electrons. And where are they? All its electrons are participating in formation of covalent bond with other carbon atoms. And because of this, again, this also answers a question when we ask you to explain why diamond is hard and heavier than graphite. You again start from here. You say each carbon atom in diamond is joined to 4 other carbon atoms by covalent bonds, resulting into a tetrahedral structure. So this gives diamond a crystal and giant 3-dimensional structure. So the structure of diamond is in a tetrahedral arrangement. Now let us look at physical properties of diamond. It is the hardest natural substance known, and this is because carbon atoms are closely packed and joined by strong covalent bonds. Read this and take note of it. So we may ask you to give a reason why diamond is harder than graphite. The answer is here. Diamond is the hardest natural substance known. Reason is the carbon atoms are joined, the carbon atoms are closely packed, if you look at this, and are joined by strong covalent bonds. The carbon atoms are closely packed and joined by strong covalent bonds. Another physical property, diamond has a very high melting point because of the strong covalent bonds of the carbon. That one we have already talked about it. So everything is arising from the strong covalent bonds joining the carbon atoms together in diamond. And why are they strong? Each carbon atom is joined to 4 other carbon atoms by strong covalent bonds, because each carbon atom donates an electron in to the formation of the bond. It has a very high density of 3.5 grams per centimeter cube, and the reason is also there because the carbon atoms are closely packed. Diamond is transparent, sparkling, and glitters. Think you agree with me, girls. Diamond is sparkling. That's why your parents use it for earrings, for necklaces, and those necklaces made of diamond are very expensive. Actually, I think pure diamond is not in Uganda. It is very hard to find someone in Uganda putting on real diamond because it is very expensive. Diamond does not conduct electricity. I've already told you the reason, because it has no mobile what? Electrons. Uses of diamond. It is very hard, and because it is very hard, it is used as a drilling device. It is used to make drilling machines. Like these you have ever seen these carpenters. There is some machine they use to drill holes in chairs, in holes. Those drilling tips are usually made of diamond because it is very hard. Then it is also used to make glass cutters. These machines which cut glass, they are made of diamond. It is used to make jewelry because of its sparkling appearance. So sometimes we ask for the use and we ask you to give a reason why diamond is used in that place because instead of graphite. So those are the two major uses of diamond. The first two are the two major uses of diamond. Now let us talk about graphite. Whereas in diamond, each carbon atom is bonded to 4 other carbon atoms. When you look at graphite, it is not the case. I want us to look at this structure. When you look at graphite, each carbon atom, like that one where I'm putting my arrow, this one here, for it is bonded to 3 other carbon atoms. Where you see a dot, that is a carbon atom. So this carbon atom is dotted to this one, is bonded to this one, then it is also bonded to this one, and it is bonded to that one. So in graphite, each carbon atom is bonded to 3 other carbon atoms. And that means carbon in graphite uses only 3 electrons since it is having 3 bonds. That means 1 electron is left free and mobile, and it is that electron that will conduct electricity. Therefore, graphite conducts electricity and diamond does not. Graphite conducts electricity and diamond does not. Because in the structure of graphite, each carbon atom is dotted, is bonded to 3 carbon atoms, which means it uses only 3 electrons since a covalent bond is formed by sharing electrons. Therefore, 1 electron is left free, and it is that electron that will conduct what? Electricity. So we are saying here, graphite consists of an infinite number of carbon atoms covalently bonded. Each carbon atom is covalently bonded, mark this, to 3 other carbon atoms, forming hexagonal rings. Forming hexagonal rings. Forming hexagonal rings that are arranged in layers. So you see this is a hexagon. It is 6-sided, so that's what we call hexagonal rings. Each layer has a two-dimensional structure. So diamond, we are saying 3-dimensional structure. Graphite, we are saying it is 2-dimensional structure. The different layers are held. The different layers are held by weak van der Waals forces of attraction, making them slide over each other, thus slippery. So diamond is slippery because the layers are held by weak van der Waals forces of attraction, which makes them slide over each other. That's the reason why diamond is slippery and soft. So since carbon atoms are bonded to 3 other carbon atoms only, some electrons in diamond, some electrons in the layer are mobile, making them to conduct what? Electricity. So this statement is exactly the same as the first one. We shall right away go to physical properties of graphite. Number 1, it conducts electricity because it has free mobile electrons. I've told you the reason why these free mobile electrons exist, because they are only the carbon atoms are joined to each other. Each carbon atom is joined to 3 other carbon atoms, meaning one electron is left unbonded. They have the melting points of graphite is high because of strong covalent bonds between the carbon atoms. Graphite is soft and slippery because its layers are held by weak van der Waals forces of attraction. So these are the van der Waals forces of attraction. These ones, these dotted lines you see going down, they are the ones that hold the layers of graphite together. Then graphite is opaque and dark, whereas we are saying diamond is sparkling. Then graphite, for it is opaque and black. Uses of graphite, I've already told you the best use is that one of a pencil. Graphite can be used. Graphite is soft and can mark, therefore used to make pencil leads. You don't have to write all this. When I ask you the use of graphite, just say it is used to make pencil leads or pencils. Then, since it conducts electricity, it is used as an electrode. Then another important use, since it is soft, it can be used, since it is soft and greasy, it can be used as a lubricant. A lubricant is that oil or what that is added to reduce friction. You know what I'm talking about. It is used to make brushes and electric motors. It is used, since it is black, it is used to protect, to form a protective coating on iron to prevent rusting. That is what I wanted us to look at today, that introduction of carbon and its compounds. But I want you to note that diamond does not conduct electricity, but graphite does. The reason is in graphite, each carbon atom is bonded to 3 other carbon atoms. That means carbon uses 3 electrons and 1 electron is left, which participates in bonding. But in graphite, each carbon atom is bonded to 4 other carbon atoms, so all valence electrons are used in bonding, and therefore diamond does not have mobile electrons. That is it for today. I have an assignment for you, only up to where we have stopped, and I wish you a good day. God bless you. If there is a question, you can ask it here, or you send it to my inbox. Now Daphne is just coming. We just wish her a good day. Any question?